and we had salt water. We supplied electricity to the setup, and we saw that bubbles were getting produced on one of the two nails. And what we also discussed yesterday is any of these activities. So while we can do various things with any activity, when we have a very specific question to be answered and answered in a scientific manner, then the way we approach the question, that changes. And that's what we are experiencing this week. So what was the question that we asked about electrolysis? So let me do a quick recap of the question itself, and then we will come to the experiments that we will conduct today to find an answer to the question. So what we talked about is, let's say after the electrolysis happens, one side, so we saw that some brown material was getting collected at the bottom of the solution, and we interpreted that that is the rusting of the nail, and hence what's getting collected is the oxide, the iron oxide at the bottom of the setup. We wanted to find out if we want to change the speed with which electrolysis is happening, the rate of electrolysis, and what all can be done. And out of various parameters, so you can of course change the electric power that you are supplying, you can change the surface area of the electrodes, you can change the electrode itself. So instead of iron nails, I can use something else which can conduct electricity. One more parameter that can be changed is how much salt we have added to water. And in fact, yesterday one of you also said that what if I don't add any salt? And based on the concentration of salt, how would the rate of electrolysis change? That is the question we want to find an answer to. So the question is, or the problem given to us is to infer the impact of concentration of electrolyte on the rate of electrolysis. And how are we going to do that? We will do a measurement of the amount of rust collected. Now, since we all are operating from home and there's no material which has been supplied for this, we also don't have access to a laboratory with equipments. We don't have weighing scale or a way to, let's say, quickly do a filtration and extract the rust out. So we need to find ways to estimate the amount of rust. So the first question I have for all of you is the amount of rust collected in given time, is that a correct indicator of the rate of electrolysis? In other words, if the amount of rust, so imagine we had a way to measure it. So I carry out electrolysis in two different setups, and both setups I place for 10 minutes. After 10 minutes, in one I get, let's say, 50 grams of rust. In another I get 100 grams. Based on this, can I say that one of the two setups is carrying out electrolysis at a higher rate, at a higher speed? Is that a fair conclusion? And is it accurate, or are we missing something? Okay, Nehan and Myra both are saying yes. Okay, so since most of you are answering yes, okay, so we have a no as well. Mohana, can you unmute and share what's your thought? What's the reason you think this is not a correct inference?
Sir, I think that if the electrolysis process is going to be faster, if you think like that, it may be because of the voltage of battery. Or else it may be because of amount of salt.
Okay,
How,
so it can.
How can we conclude it as the electrolysis process is fast, and in this electrolysis process is slow, like RYSI said.
Okay, so let me repeat the question, right? It's good that you shared your thought because it's helping me clarify. So I think what you're saying is the electrolysis rate can be higher or lower depending on various parameters, not just concentration of electrolyte. It could be because you supplied higher voltage. That's a very fair point. My question is, how do you conclude that the rate of electrolysis? So this is not like the speed of a moving object, right? We are talking about the speed of reaction. So what should be the parameters that we observe for us to conclude whether the rate of electrolysis is high or low? And there I am saying, if I have a way to measure the amount of rust collected at the end of the reaction, so of course I'll leave the electrolysis for the same amount of time. Then in given time, if the amount of rust collected is more, then can I conclude that the rate of electrolysis is higher? That was the question. So Mohana, can you unmute yourself and respond? Ashay,
Not able to find her, Vishal. 1 second. I'm just locating her.
and
No,
I
she
think
dropped.
okay, that's fine.
She might have gotten dropped,
Yeah,
Vishal.
yeah.
Even I can't find her.
That's fine. So let her come back. In the meantime, those who have responded yes, also tell me which one you think is showing higher rate of electrolysis. So I have set up one where after 10 minutes I've got 50 gram rust collected. I have set up two where 100 gram rust got collected after 10 minutes of electrolysis. Which one is showing higher rate? Myra is saying setup two. And here, anyone else? There are many of you who said yes. Okay. Yeah, setup two with 100 gram rest. Yeah, and of course, this is a simple question. There's no trick involved here. It was just a quick wake up check for me whether you all are awake and you are with me or not. So yes, the setup which is preparing more rust in a given time. So now let me give a slightly different situation. So I have set up one which I leave for 10 minutes. It collects 50 grams. Set up two, 10 minutes. It gives me 100 gram rust. Set up three, which I leave for 5 minutes, and it's giving 50 gram. What do I conclude? Which one has the highest rate of electrolysis? Okay, Karur is clear. Set up three. Okay. And can one of you unmute yourself? So let me, Karur, you were the first one. Why don't you unmute and speak? How did you arrive at the answer setup three? Karur, you are there? My intent is not to put any of you on spotlight. I just want the discussion to start flowing so that before we start conducting the experiments, we are prepared and we are aware why we are conducting these experiments.
I've asked him to unmute. Not responded.
And aren't I thought they can unmute themselves. Yeah, they are allowed. Okay, so maybe not Karur, then anyone else who wants to unmute and speak. I just want to understand your thought process. That's the only reason. Ehan or Suchi, Prisha, Myra, any of you?
Yes. For 5 minutes, the setup 3 collects 50 grams of rust. The others, the setups collect like the setup 2 collects 100 grams of rust in 10 minutes. So
Mhm.
if in 5 minutes we double it, we get 100 grams of rust. So
So then,
that's concludes as the highest amount of rust.
yes. So if we were to define a unit for measuring the rate of electrolysis, what unit would you choose? Let's say I want to, what is the unit I would use for measuring the speed of a moving object? Let me ask that question.
Sir, I think that for measuring the rate of electrolysis, we can take the unit that amount of rust collected per unit time.
An amount of rust collected per unit time. So
Sir, I
that's
think I know it. Like we can use the unit grams per minute.
grams per minute. Okay, so let's do that. So it's good. Both you and Prisha kind of are thinking in the same direction. So now tell me, what is the grams per minute, which tells us the rate of electrolysis for setup 1, for setup 2, and setup 3. So setup 1, 50 grams in 10 minutes. So what would be the rate?
5 grams
Five,
per
sir.
minute.
5
5
grams.
grams per
5
minute.
grams per
Setup 2? Yes, Myra. Setup 2 is how much?
Just 100 grams in 10 minutes, so we can.
10 grams per minute. And setup 3?
10 grams per.
Yeah, so then isn't setup 2 and setup 3 same?
Yes, equal.
Yes, sir.
They are equal, right? Only thing is, we can conclude this to be the rate, but I want to draw your attention to the fact that the way, even in speed, we say that it's not, so it's possible that one person travels 50 kilometers in 1 hour, but in between that person had a very high speed, whereas someone else is continuously driving at 50 kilometers per hour. Whereas someone else may have gone to 80 kilometers per hour in between, 30 kilometers per hour in some time. So what we are getting at the end is the average speed. In the same way, it is the average rate of electrolysis. So it's not necessary. We still don't have enough data to conclude that the setup 3, which produced 50 grams in the first 5 minutes, will it produce another 50 grams in the next 5 minutes, or will it produce 70 grams, or will it produce 30 grams, which is also known as linear or non-linear relationship. In case you have not studied this in maths, you may come across that. But I just wanted to call it out, just comparatively a small point. So coming back to the question, I can infer the rate of electrolysis based on the amount of rust which I have collected after I leave the electrolysis for a fixed amount of time. The problem is I don't have a way to measure the amount of rust, and hence one method which Shivani came up with is, she's saying you leave each setup for 10 minutes and after that observe the color of each setup. If the color is darker, it means more amount of rust has got created, and hence we will infer that the rate of electrolysis was higher over there. Let's also quickly revise the 4 options that we looked at yesterday. And the 4 options were: 1, we wanted to predict what will happen. Okay, for that we had 4 options, and we also had 4 different hypotheses. So we had these 4 options. In one case, we are saying the rate of electrolysis will increase as we increase the salt concentration, and it will continue to increase. So if I add 10 teaspoons, I'll get certain rate, let's say 20 grams per minute. With 15 teaspoons, I'll get, let's say 25 grams per minute. With 50 teaspoons, it will continue to increase. So it will just keep increasing. Second option is it increases initially and after some time it will remain unchanged. Third option is it will increase, after some time it will start decreasing. And fourth option is from the beginning, as I add more salt, the rate will start decreasing, and after some time it will remain unchanged. So it will decrease initially. Also, let's recall the hypothesis very quickly. So one theory was that if we add salt, it will provide ions to the solution, and hence the charged particles, number of charged particles will increase. So the current flow will increase. Basically, the same water will become a better conductor of electricity. Second, we are saying it will become a better conductor of electricity, but the reason is not ions or charged particles. The reason is that by adding some solid into the liquid, the particles of that solution, they are coming closer to each other. That is the reason it becomes a better conductor of electricity. Third, we are saying the salt will lead to some positive and negative ions in the water. So positive ions go to one terminal, negative to another. So there is a potential difference created, and hence the voltage supplied to the system increases, which also is similar to what Mohana was saying. So she is saying that if the voltage supplied is increased, the rate of electrolysis may go up. The question though is, if the hypothesis C is correct, and we are also claiming that just by adding more electrolyte, the voltage supplied to the system is increasing. And there's a small difference there. Hope you are clear about it. And option D is pure water is better conductor of electricity compared to impure water, because impurities come in the way of the flow of electricity, and hence by adding more salt, the rate of electrolysis will come down. Okay, so what we will do is we'll prepare these different setups with different salt concentrations and observe the rate of electrolysis and come back to the results as well as the hypothesis. Any questions before Shivani takes over and conducts the experiments with you? Okay, Shivani.
Yeah, so in today's experiment, I'll be testing for 4 different concentration. So in each of these cut bottle, I'll add 100 ml of water.
How many of you guys have the materials with you? Only 2?
So in each of these bottles, I've added 100 ml of water. So these things I have already made for these wire
Excuse me,
connections.
ma'am.
Yes.
Ma'am, I have two bottles, so I will be able to make 2 setups at one time.
Okay. I guess it would be good if you arrange 4 and you can see how the rate of reaction is affected with concentration. It would be really good if you observe that. So now I'll add salt. This is the salt packet. So in first one, I'll add one spoon. Second, I'll add 3. In the third one, I'll add 6. The last one I'll add 9 spoons. And just give it a stir. Okay, just wait a minute. I'll be back.
Can you all identify the dependent variable here?
So the dependent variable is the rate of electrolysis.
The rate of electrolysis is what we want to infer. What is the variable that we are observing to infer the rate of electrolysis?
So the amount of rust collected.
Amount of rust collected in given time. Yeah. And what is the independent variable?
Sir, amount
So
of
the
salt.
amount of salt added.
Amount of salt. And what are the controlled variables?
So the control variable are the voltage of the battery and the amount of water.
Amount of water and the voltage of the battery. Okay. Any other variable that we need to control? Anyone else?
Say the size of the nails.
Size of the nails. Yes. Size of the nails. And Mohana, why is the size of the nails important? Why should that be same?
So because if we insert if we insert the nails with less size, we'll get somewhat less rust.
And less size means what? So let's say I take
So
two
the
nails
deposition of
which
the
have the
rust.
same length, but one has more thickness compared to other. Is this change okay?
So the deposition of the rust on the iron nail will take less if we keep
I'm
the
saying
small
that.
iron nail.
Not sure I understood what you're saying, Vinyashi.
So the deposition of the rust on the iron nail, if we keep the small iron nails, will be less if we keep the small iron nails.
Yeah, and I'm asking what exactly does small mean? So if I have the same length of the nail, but the thickness is different, is that okay?
Yes, sir.
Now, Mohana, what were you saying?
So both the thickness and the size of the nail should be small for
Okay.
only one nail, and the other nail should be opposite of that.
And why are you saying that? What are you thinking?
I mean, the deposition of the rust on the small nail will decrease when we insert the less sized nail. Likewise, I'm saying.
That is right. So what I want to highlight is that if I take a thicker nail, then if it's the same hand, if I'm able to make a bigger circle, then the total surface area of the iron which is dipped in water, that increases. Then the amount of electrolysis, the rate of electrolysis, that will get impacted. If I take a thinner nail, then the surface area of the iron nail exposed to water, that will also change.
Yes.
What about the level of water in the container? So let's say the container, I take a wider container once and a
The container, which will cover the half of the iron nail.
yes. So are we saying that the level of the iron nail dipped in water should that also be controlled?
Yes, sir.
Yes.
I mean, so the top should not cover, the top of the iron nail should not be dipped in the water, just a half of the iron nail.
And why are you saying that? What will happen if the top also gets dipped? I would say that majority, so as much as you are able to dip, just that we want to control the amount of water, and in 100 ml water, maybe you are not able to make the entire nail dip. But if 90% of the nail gets dipped in water, that's better, because then you are maximizing the surface area. Only thing is, the in setup one setup you keep 3/4 of the nail dipped, another setup you keep half nail dipped, then your results will be inaccurate. So the level of the iron nail dipped in water, that's also one of the variables we need to control.
Yeah, so sorry for the delay. Actually, that was not the salt. I had added something else. So I just bought the salt and have added that. Yeah.
So now these 4 setups, they have salt, Shivani,
Yes,
or
yes.
something?
Yes, yes, that's salt.
Why does the water appear to be more in that rightmost container? I hope the level is same.
This is, yeah. It has 9 spoons of salt, right?
Oh.
This is having 1 spoon, 3, 6, 9.
And if you look at the levels, are the levels same, level of water?
No.
This seems to be same. Those first two seem to be almost same, right?
Yeah.
Okay.
This is having 9 spoons.
And why would, so the water taken was 100 ml,
100 ml.
but now the level is higher.
Yes.
And that's because of the undissolved salt, huh?
Yes.
Okay.
So now what I have done is I have made this wire setup. I have made 4 sets. And instead of taping it inside, I have done an arrangement, like I have made holes in the toothpick that I can like simply insert it inside and just place it in. So that nobody complains that the last one took a lot of time. So the rusting was less.
So children don't need to have the same setup, right? They can directly tape.
Yes.
those of you who are working in parallel to Shivani, if you have already initiated the reaction in any of your setup, please keep track of the time. Ensure that all the setups, they are placed for the same amount of time.
So now I'll insert all of these. And set a timer for 10 minutes. Set a timer.
So please raise your hand once you are also ready with your setup, so that by the time the electrolysis happens, we can have some discussion.
If anyone is doing along with me, just you can show their setup.
Isha, are you trying out?
Yes, ma'am.
How many setups?
Ma'am, I have only two.
Two?
Yes, ma'am.
How about Mohana? Are you trying to?
So Prisha, how much amount of salt you are adding in the first and the second?
And in the first one, I have added 1 teaspoon. In the second one, I have added 3 teaspoons.
Okay. Anyone else?
All their videos are off, so can't make out.
And I have prepared the two setups.
Okay, now set a timer for like 10 to 15 minutes and see
Yes,
the
sir, I
difference.
will set. Yes, ma'am.
So while the reaction continues, let us have some predictions done. So, okay, wait. Let me first define the 4 setups for you. So after the reactions are done, or rather after we have left the setup for 10 minutes, what we will do is some rust would have got collected in the solution. We'll let it settle at the bottom so that the color is visible. At the end of that process, what we need to do is to arrange the 4 setups in the decreasing order of darkness of color in the solution. So you have setup 1, which is the 1 teaspoon setup, 2 with 3, 3 with 6 teaspoons, and 4 with 9 teaspoons. And based on this, I want you to, so before the results come, let's have a quick prediction. The poll question is visible, Lakshmi?
Not
Yes,
to me,
Vishal.
Vishal.
Yeah.
It's visible, but we're not able to answer.
Oh, really? Okay. Let me launch
Yes,
it again.
it's saying 0% to everything, and we're unable to answer.
Okay. Just one minute. Let me launch it again.
It got stopped. Yeah, now it's relaunched.
Yeah, I didn't relaunch. I think I had
Stopped it.
Mhm. since we are anyways waiting for the reaction to happen, we don't mind waiting a little longer to get more votes. So even if you are not sure, please vote, because no one is going to find out who gave what answer. I've got only 13 so far out of I think the 22 of us who are here. Okay, let me end the poll here and we can look at the results. So out of the 15 who voted, 9 believe that the last setup, which has 9 teaspoons of salt, that should have the darkest color. One person thinks it would be setup 3, whereas 3 people feel that setup 1, which has the least amount of salt with 1 teaspoon, that will have the darkest color. So the rate of electrolysis will be highest in setup 1 according to these 3 people who voted for setup 1. 2 people have also voted for setup 2. Which one will have the lightest color? Again, majority. Only thing is, for some reason, the number of people who voted for setup 1 is 10 and not 9, which means it may not be the same set of 9 people who voted for setup 4 as darkest. Maybe someone feels that setup 3 will be darkest, but setup 1 will be the lightest one. I'm just making a guess. Setup 2, one person has voted as the lightest color. One has gone for setup 3 here as the lightest color. So some people have also said that setup 4 people have voted for that. Okay, very nice. We will know very
Time is
soon.
up.
Time is up. Okay.
Yeah. So what I'll do is I'll just shake it a bit. And
So as you are shaking, the color seems to be becoming darker, Shivani.
yes, yes. Yeah. So this is the result.
So setup 1 is towards your leftmost, right?
Hmm. Yes,
So-
this is having only 1 spoon of salt. This is with 3. This is with 6. So basically, it's increasing and then decreasing.
But based on the view that you have, is setup 6 darker than setup, sorry, 6 teaspoon is darker than 3 or lighter?
Lighter.
Okay. So you have the most visibility.
Yes.
Wait, let us see how if people are observing. Okay.
Why is setup 1 yellow and the others sort of bluish? Do you
I
know?
don't know.
Bring it closer to the camera, Shivani.
It's actually light green.
Greenish.
Yeah. So can I say, ask Prisha, how's your solution? What's the color? Can I see your color?
Excuse me, ma'am. Ma'am, I did the setup. The setup I did by adding 4 tablespoons of salt, and this is what I got the result. 1 second.
Can someone try with 9 spoons of salt and can show me what did they get? Oh wow, yes. It's dark
dark
green. Is it brown or green?
Dark green.
This
Okay.
is this was also left for 10 minutes. Vinyashi?
Yes. Yes, sir.
And what did you supply? Did you use the 9-volt battery?
Yes, sir. I used the ASL battery.
Can you show the setup? I'm just surprised how. So how much salt you had added? This was 4 teaspoons.
4 tablespoons of salt.
4 tablespoons or teaspoon.
Yes.
Okay. Yeah, this is much darker, and I wonder why, because the amount of water also seems to be similar, around 100 ml.
Look at this layer of water there. What is that?
Sorry,
What's that in between layer of water?
ma'am. It's the salt is in the bottom of the bottle. I mean the container,
Okay.
and the water looks like light green color.
Can you take out those? I can see that there are screw threads as the head kind of thing. So these are probably not same iron nails. I'm trying to explain why there is a difference between the results you have got and what Shivani has.
Should I take the iron nails?
It depends
And
upon the
take it
salt
out
also,
because
right? Some is
salt,
iodinized and yeah.
no, it should not.
What
I
kind
mean,
of salt?
Common salt.
Okay.
these are iron nails only, Vinyashi?
Yes, yes, sir.
Or is it some kind of a screw? I'm trying to see if the metal is different.
No, sir. These are the iron nails.
Okay.
It looks like screw.
Yeah, these are screws. Don't touch them to each other, because otherwise your battery will short. Okay. Yeah, so maybe that is making a difference, because if the metal is different, this may be some alloy, some mixture of iron and another metal. Okay, anyone else who has prepared the setup? Risha?
So actually my second setup did not work, so I'm making it again. But the first setup did work, and after 15 minutes, this is the color.
There's a lot of light from the window, so maybe the color, yeah. So the reaction is still going on, Risha?
Yes, sir.
Can you do what Shivani did? That is, remove the nails. You can stop the reaction. 10 minutes are over.
Yes, sir. 15 minutes are over.
Yeah, you can remove and maybe shake it. Sometimes if the connection is not neat, then the electricity doesn't pass through, and that's why the reaction doesn't happen. Yeah. This was how many spoons of salt?
1 teaspoon.
1 teaspoon. Can you not let the iron nails touch each other? Because otherwise your battery, it will just... Even this, the color is different, Shivani. I mean, this is not yellowish. It seems to be on the greener side. Rishabh, what's the other setup?
So I'm still preparing the second one again soon.
And that is how many teaspoons?
So 3 teaspoons.
3 teaspoons. Okay. Okay. Anyone else? I just wanted to quickly share my own story, one of the experiences I've had. So I was with the software industry for a long time, for a good 11 years. And for the last 11 years, I've been working with children and teachers in the education space. So after I left my corporate job, and the first project I did with children was to set up a windmill. Okay. And it was a very ambitious one that the people who had the land, they readily agreed to give us the space. But to make the windmill, the requirement that we came up with is first to make a generator. And to make a generator, we had to first make a model of a generator. And we made a very basic model with a cardboard tube around which we wound wire, put nails and magnet, and we would manually rotate the nail and the magnet, and current will get produced. When I was working on that project with children, one big realization for me was the toughest thing for me in that project to make the generator was to cut the cardboard. And it was such a hard slap on my face that I used to feel it's all about that I should be applying the Fleming's right hand rule and talking about how electricity is produced, and then extend it to turbines and have windmills, etc. But the challenges was not any of those. It was not any of the hi-fi engineering. The toughest thing was to prepare that contraption with the rubber and the cardboard so that the nail stays in its place. It's one thing to look at a demonstration, and in today's world, when we have almost infinite number of videos and pictures on the internet, we sometimes feel that, oh, I've seen it and I know. But I just want to say that the two things are not equivalent. It's not same to see something, and it's a different thing to understand. And for filling that gap, to moving from seeing something, seeing a demonstration, seeing a video, to yourself experiencing and understanding, you need to do things yourself. You need to jump into the water. You need to wet your hands. So it's great that Shivani has prepared this detailed setup, and you are able to see the results. It's also so nice to see Prisha and Vinyashri also preparing these two setups, and which is giving us some more data. Had we had all 20-25 of us generate some data, that would have made it richer, because what if there is some error in the setup which any of these three have prepared? There's no way for us to find out if there is any error, and hence the conclusions that we may draw. In fact, I would resist from drawing any conclusions, any inference based on just 3 data points, because it's very easy, especially when things are done manually. We don't have machinery, we don't have any sophisticated instrument or a laboratory here. And the reason I'm calling out is this entire program is about innovation and scientific literacy, and we are talking about all the big things. But the basic thing, if that's not done, which is to come prepared with the material, someone is bringing all the experiments right at your doorstep through the computer, working so hard. What is least expected from you is to come prepared with the material when the material list is given to you in advance, and to actually perform the experiment. That's the reason we didn't leave this as a homework, because we thought the data that we may collect, that is the observations that you collect, maybe there are errors which are made, so we wanted to do it live. But if you don't bring the material, then we won't be able to do much. And the entire discussion around scientific literacy, it's irrelevant, because the premise of scientific analysis is to have observations and have data, but we don't have data, right? And the reason I thought of talking about it very frankly to you, so it's not a complaint, and obviously given that this is a free program and we won't be able to do much if you bring the material and you work on the experiments or not. The reason I'm bringing this up is hopefully if you agree with me, then tomorrow and day after, when we work on the other experiments, the next one, at that time you can come more prepared and make the program more meaningful. Otherwise, there's no point. It doesn't encourage us to continue to invest so much effort. So let me share what is the next experiment, and after that we can close today's meeting. So we'll also share what is the material required. Obviously, it's all there on the website, the Raman Awards page, but maybe calling it out explicitly may be helpful. So we are going to work on thank you for not making all of us listen to the television. So the next experiment we are going to work on is to measure the reaction time of our body. So reaction time, there are three different, so either after seeing something, I send a signal to my brain, and then the brain asks our muscles to take an action, or I may listen, or I may respond to a touch. These are three different external events to which our body is responding, and we are going to make some measurements through few experiments and infer the three types of reaction time: the visual response, auditory response, and the touch response. And for that, there is a specific setup. You'll need preferably a 1 meter ruler, but if you don't have that, 30 cm can also be used as a compromise. You'll also need one more person to be with you when you are
Sir, your voice
doing the
is
measurements.
breaking.
Okay, is it breaking for everyone?
No, Vishal.
No, Vishal.
You need to bring a 30 centimeter ruler if you don't have a 1 meter or a 60 cm ruler, and you'll need one more person to be with you for conducting the measurements. Material wise, it's pretty simple, so hopefully we'll be able to collect more data tomorrow. I'm choosing to skip the discussion related to electrolysis because I'm not sure it's if we really want to learn something, it has to be a two-way effort. We cannot always just drive from our side. So I think we will be meeting again tomorrow at 3 o'clock, and we can end the call here.
Sir, what are the materials required for tomorrow's project?
I just spoke about
Sir,
it.
Sir, due to some internet problem, I have rejoined the session. Can you
A 30
please repeat?
centimeter ruler if you don't have a 60 centimeter or a 1 meter ruler, and one more person to be with you for conducting the experiment.
Okay, sir. Thank you.
Excuse me, sir.
Yes, Prisha, do we have, are you able to see the bubbles on the setup?
Yes, sir.
Nice. So why don't you collect data and you can share with us with any of the admins on the WhatsApp group, and we will forward it to the group as well.
Okay, sir. So actually, I just wanted to know that I am out of station, so I might not be able to arrange a 30 centimeter ruler. So I only have a 15 centimeter ruler right now.
Yeah, 15 centimeter may not work. So the other option is we'll share a template. So is it possible for you to take any printout?
I think so.
Yeah, so we have a template, so you can print and paste it on a cardboard. That way you'll be able to make your own 1 meter ruler.
Okay, sir. Thank you, sir.
Okay. Okay. Bye everyone. We'll meet tomorrow.